Hello, my name is Jorge Sanes. I'm from Colombia. I play the guitar and other instruments, and a couple of years back I started recording myself and my band in my home studio. For this week's topic, I chose typical recording signal flow using your own equipment, so I'll be talking about the different scenarios of signal flow in my studio. I'll be covering signals coming from my guitar, my microphone, and from within the computer itself, specifically from a virtual synthesizer. Finally, I'll talk about the signal flow coming from the computer to the outside world via speakers and headphones. Let's get started with the signal from my guitar. Since I mainly play the electric guitar, let's talk about the signal flow starting with an electric guitar. I always connect my guitar, a Fender Strat, to my multi-effect guitar processor, a Zoom G9.2 TT. The G9.2 TT can function as an audio interface, but I don't use it as such because it has a quantization bitrate of 16 bits, whereas my audio interface has one of 24 bits. So I connect the G9.2 TT to one of my amplifiers and put a mic in front of it. I use a Takstar SM8B. Before using a mic, I connected the G9.2 TT directly to my audio interface, an M-Audio Fast Track working at 48 kHz sampling rate, but the sound I got wasn't that great. Well, the mic goes to the audio interface and there to my computer via USB and to my DAW Ardour, which is free and open source. The DAW, or Digital Audio Workstation, is the final link in the chain for input of sound. When using a mic, the signal goes from the mic to the audio interface and to my computer and DAW. Now let's talk about each step in more detail. First, the guitar. An electric guitar has a series of input transducers called pickups, which capture the vibration of the strings above them and turn that into electrical current. This information is sent through a TS cable to the multi-effects processor, which is amplified in the preamplifier and then converted to digital data in the AD converter. The digital data is then processed and shaped. After this, it's converted to an analog signal and sent to the guitar amplifier through another TS cable. Now the microphone comes into action. A microphone is another type of input transducer which converts air pressure variations into electrical variations. These air pressure variations can be produced by a guitar or bass amplifier, the vocal cords, or other instruments like the flute and the acoustic guitar, which I also use in my studio. From the microphone, the electrical current goes to the audio interface through an XLR cable. Most audio interfaces function as a preamp and DA, or digital to analog converter, so this current gets amplified and converted to digital before being sent to the computer via, in my case, an USB cable. Notice that the signal flow has been converted back and forth between analog and digital through the chain of devices I use. The multi-effects processor converts it from analog to digital and then again to analog to be reproduced by the guitar amplifier, and then the audio interface converts it from analog to digital. But when the signal reaches the audio interface, it remains digital and it's not changed until it's time for the output signal flow. Now, within the computer, you can send information to the DAW, for instance from a synthesizer, and this process is kind of the actual physical process of connecting cables. Using patches, I can connect to the different modules, synthesizer, MIDI sequencer, and DAW. The synthesizer I use is Synapse SubFX software synthesizer, and the MIDI sequencer is Rose Garden. If I'm performing live, then I connect the synthesizer to the DAW. But if I have created a MIDI file, then the MIDI sequencer comes into action. I connect the MIDI sequencer to the synthesizer so the sounds get played at the correct time and with the correct velocities, and the synthesizer to the DAW. Now, when it's time to hear how your work is going, or simply when you hit a note in the synthesizer, the second part of the signal flow comes in. From the DAW, the signal goes to the audio interface via USB. There it's converted from digital to analog and gets preamplified. Then it's converted from voltage variations to air pressure variations by output transducers, which are speakers, in my case a pair of M-Audio AV40 studio monitors or headphones. Now a bit about monitoring. Well, there are many ways to monitor while you play or sing, making different kinds of connections and using DI boxes. There is a simpler way to achieve that. Modern audio interfaces come with the feature of direct monitoring. This means that the input signal is sent directly to the headphones or speakers at the same time as it's sent to the computer. thus allowing monitoring with zero latency. Many home studios will have a different array of devices and configurations, but the basic signal flow is the same in all of them. First comes the sound source, vocals, guitar, drums. Then microphones convert the air pressure variations into electrical variations. From there, the signal goes to the audio interface, where it is amplified and converted to digital information. Then it's sent to the computer and to the DAW. From the DAW, it goes back to the audio interface, where it's converted to analog and gets amplified. Finally, it goes to the speakers or headphones, where the signal is converted to air pressure variations or sound.